In After Effects CS5 and earlier, the camera depth of field blur tended to calculate slowly and didn't really look all that good. Well, this changed as of After Effects CS5.5, where the camera now gained a large number of iris-related parameters. The iris being the opening in a camera which determines the shape and quality of the blur. The default is fast rectangle, which is how After Effects CS5 and earlier looked. However, you now have a long list of different basic iris shapes, from ones that can be quite graphical, like triangle, to ones that are more similar to a real camera. Hexagon is a 6-vein iris, heptagon is a 7-vein iris, etc. Hexagon is a good typical camera look. I'll take a snapshot of that for comparison, and go back to fast rectangle for comparison. Very much like a box blur compared to the more realistic hexagon form. These various blur parameters were both added to the camera and also to a 2D effect called camera lens blur. To explore these parameters, sometimes it can be faster to work with a 2D version of this blur than to work with 3D space, which can be more computationally intensive. So just for the sake of learning what these parameters do, I'm going to open up a new composition, O5C Camera Lens Blur Starter. And I'm going to go back to one view and make sure that I can see this at 100% magnification. Camera lens blur works particularly well when you have a lot of contrast, little highlights like light sources compared to an otherwise darker background. That's where you can really see nice lens blur patterns. I'm going to select my 2D footage and apply Effect, Blur and Sharpen, Camera Lens Blur. As of After Effects CS5.5, this replaced the old lens blur effect, and apply it. And now you see some nice circular highlights for these blurs. I'm going to increase the blur radius so you can really see what's going on here. Now we can see some pretty large shapes. And for this effect, I'm going to turn on repeat edge pixels. That means don't blur the alpha channel, just blur the RGB channels. You don't need to worry about this with a normal 3D camera blur. Now you have a much better view of what's happening with the different shapes. Triangle, which now has a very obvious shape to it. Square, and by the way, you can rotate, so you can be very graphical, such as this, or even animated to create some interesting graphical effects. I'll return to 0 for now. And other shapes up through decagon, a 10-sided iris, which is almost round. These more complex shapes tend to take longer to render than, say, the fast rectangle we had back with the 3D camera. However, you can round these shapes out. I'm going to go back to something like, say, pentagon, which is a 5-sided shape, and play around with the roundness parameter, where I can make it a completely perfect circle, or something in between with just a little bit of bowing to the sides of that iris shape. You have aspect ratio. If you shoot with an anamorphic camera, your blurs tend to take on different shapes. So you set that to match your pixel aspect ratio. And diffraction fringe, which is kind of a fun effect. Again, take a look at how nicely filled in these circles are. As I increase diffraction fringe, you'll notice that the brightness tends to creep out more towards the outside of the circle, and it tends to be less bright or less luminance in the middle of the circle. Diffraction fringe of 0, fringe of a maximum of 500. And again, this is another path to a more graphical look, particularly as we try out larger blur radius settings, such as around there. Another area very much worth exploring in both the 2D camera lens blur effect and 3D cameras is the highlights section. It's the ability to pump up the gain of specular highlights brighter than they would normally be, which can give them that extra pop in a scene. The two main parameters are gain and threshold. I'm going to crank gain up for now. Now you see my bright circles getting even brighter. Threshold is very important as well. This says above what luminance value do we brighten those highlights. Now with the 3D camera, this defaults to the highest value, 255 out of a 0 to 255 range, which means virtually no pixels qualify to be increased or to have gain applied to them. I far prefer the default value in the camera lens blur effect, which allows the top 20% or so of your luminance values to get this extra gain. In this scene, which is predominantly dark, I might even lower it so that more of my brights get pumped up by this gain setting. Again, that's gain 0, gain 100. As you increase gain, you'll notice that these highlights start moving towards white. If you want to get color back in these highlights, increase the saturation parameter. I tend to like colorful, graphical looks and don't worry all that much about realism, so quite often I will increase the saturation to get my color back in these highlights and create a more colorful scene. Again, before and after maxing out the saturation setting. Again, these highlight settings and these iris properties are identical between the camera lens blur effect applied to 2D footage and 3D cameras, and you'll see all these parameters down here in the timeline panel. The camera lens blur effect has one more advantage of allowing you to apply a blur map. In this way, it becomes a compound blur effect, where you can look at another layer to decide what sections of this layer will receive the blur. And we talked about compound effects in depth back in the lesson on nesting and precomposing compositions. So that's camera lens blur and also depth of field blur in After Effects. Again, as of After Effects CS 5.5, there was a major change in allowing you to have more control over how those blurs actually looked.